We're going to work on organizing and displaying data. We're going to start by talking about grouped frequency distributions. As we take a look at this language, a frequency distribution is the frequency means how many, and distribution means a list. So we're really looking at a list that's been organized to tell us how many are in each group. So we've got a distribution, it's not grouped, so we've got a distribution or a list of ages here below, and we want to create a frequency distribution with 3 classes. So we're going to start with a range. The range is the maximum minus the minimum. So I want to take the maximum minus the minimum. For this data, our max is 32, and our minimum is 16. So that gives me a range of 16. So we've got 16. To figure out the class width, we're going to take the range and divide it by the number of classes. Okay, so I'm going to take 16 and divide that by 3. Whenever we're doing these ranges, I'm just going to grab my calculator here, and then dividing it by the number of classes, we are always going to be rounding up. If we round down, then we're going to miss including all of the data values. So for this one, 16 divided by 3, which I could have done in my head, I guess, I get 5.33333. I'm going to round that up to 6. Even if it was 5.0, I would still round it up to 6. So we always round these up. So as I round this one up, it gives me a class width of 6. So as always, round up even for no decimal. So for example, if you did your range divided by the number of classes, and you ended up with, say, the number 7 or something, even, I would still round this guy up, and my width would be the next whole number, and in this case that would be 8. Okay, so that's just an example there. So let's go ahead and put this together. So my class limits are going to start with the minimum value, so 16. And as I move through this, let me just scroll here so we can look at, there we go. And as I work through with my class limits, I'm going to use that class width to get from the first lower limit to the next lower limit. So I'm going to add 6 to get to the next lower. That's going to be 22. And then I add 6 again to get to the next lower, which is going to be 28. To get my upper class limits, I'm going to backfill. To get to 22, I would need a 21 before that. To get to 28 in the last group, I would need a 27 before that. Notice how here I'm also adding 6 each time. So to get to that last class limit, I'm going to add 6 again, and I end up with, that would be 33. You'll notice that the class width does not show up between the lower limit and the upper limit. This difference is 5, but my class width is 6. So for the limits, that class width shows up going from lower limit to lower limit. Let me erase part of what I've got here so I can go ahead and finish my boundaries. As I go to the boundaries, I'm really taking this from what is a discretely treated variable is age, to a continuous one. And I do that by using my 0.5 adjustment. So it's plus or minus 0.5. We call this the continuity adjustment. So what I want to do is to take my class limits, and I'm going to bump them out by 0.5 so that my boundaries are now touching. So the important thing to remember is that the boundaries are touching as you go from class to class. So using my 0.5 adjustment, I'm going to start with 16 and subtract 0.5. So that's going to give me 15.5 too. Then I add 0.5 to the upper limits, 21.5. So let me grab a different color pen here. So I'm subtracting, I want a different color. There we go. So I'm subtracting 0.5 to get the lower boundaries. I'm adding 0.5 to get the upper boundaries. Okay, so continuing, remember these touch. So I know I've got to start at 21.5. Whoops, I want blue. Okay, so this is going to be 21.5. Up to 27, I'm going to add 0.5, so 27.5. So 27.5, 2 to the 33, I add 0.5, 33 13.5. Next is midpoints. To get the midpoint, so MDPT, I'm going to take the lower limit plus the upper limit and divide it by 2. So I'm averaging those. So the lower plus the upper divided by 2. And it doesn't matter if you use limits or boundaries. I'm going to grab my eraser. I'm going to clean things up a little bit. Clean things up. There we go. Let me clean things up a little bit as I move into my next column here, blue. Okay, so now I want to take the midpoint. So to get this first midpoint, let me write it over here. I'm going to take, and you could use the boundaries or the limits, it doesn't matter. The limits are just a little cleaner, but you'll get the same answer. So I'm going to take 16 plus 21 and then divide that by 2. I'm going to grab my calculator here. So let's put this in parentheses so we can do this all in one step. So parentheses, 16 plus 21, lower plus upper divided by 2. And we end up with 18.5. So that's going to become my midpoint here. So I get 18.5. I could continue to do my formula for each of these midpoints, or I can use the fact that my class width is 6, and I can go ahead and just add 6 to get to each midpoint. So if I add 6, I should get 24.5. Let's check that next midpoint with a calculator. This one is going to be second class, 22 plus 27 divided by 2. And sure enough, it's 24.5. So let's go ahead and just add 6 to get to the last one. So if I add 6 again to get to that last midpoint, that's going to be 30.6. And again, you could check that using the midpoint formula. Okay, so again, just kind of erasing my little notes there as I go. Let me go back to my pen. Next is the frequency. So the frequency is my count. So I'm going to go ahead and count my values in each of my classes. I'm just going to use class limits. So I'm going to go from 16 to 21. So that first group, 16 to 21, goes here, and I'm just counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in my first group. Second group includes 22 through 27. So that is these 3. And then my last group, 28 through 33, and I have 2 in that group. When I total my frequencies, we call this N. 10 plus 3 plus 2 is 15. I'm going to use this number to find my relative frequencies. My relative frequencies is going to be my frequency over N. So relative frequencies, these are frequencies divided by N. So I'm going to start with 10 divided by 15, and I can just put this into my calculator to get, where's my calculator? So I can just put this into my calculator, there it is, to get a decimal version of this. The fraction is fine as well. So 10 divided by 15 gives me 0.67. I don't know if you even saw that. So you can just trust me, 0.67. The next one would be 3 out of 15. If you put this into your calculator, that one is 20% or 1/5. And then finally, we've got 2 out of 15. So if I do 2 out of 15, that is 0.133. So let's do 0.133. So 2 out of 15, 0.133. If I add up all of my frequencies, I should end up with 1 being the total. So the sum of these frequencies, I'm going to write this sigma out in front. This is sigma, which means sum. Okay, this is sigma, which means sum. Okay, so a lot of new symbols here. So the sum of all of those frequencies is going to be 1, or you could think of that if you were in percentages, or 100%, all of my data. Finally, cumulative frequency. Cumulative just means a running total. So I'm going to just link this with my frequency column to get my running total. I start with 10. As I read these cumulative frequencies, it means up to. So up to age 21, I have 10 people. The next one is going to be up to, this is going to include everybody in my first and second class. So that's going to be up to 27. And I do 10 plus 3 for 13. For my last cumulative frequency, this is up to age 33. This is everybody, but I just grabbed that last limit. So up to 33, I add 2 and I get 15. And then you notice that this cumulative frequency of 15 in the last row matches my total frequencies of 15. Okay, this is the grouped frequency distribution. You'll also see this abbreviated as a GFD, which I think is kind of funny, but you'll see it both ways. So GFD or a grouped frequency distribution. Let's go ahead and take a look at part D. So in part D, I want to come up with a histogram using my grouped frequency distribution. To do my histogram, I want to create bars that are touching. So I'm going to be using my class boundaries to do that. So I'm going to use my class boundaries. Then I'm also going to be using my frequencies. So just looking at, just let me select it. So just looking at both of these columns, so the frequencies and the class boundaries are going to make up my histogram. My histogram lives in just a single quadrant. So I can go ahead and draw it here in one quadrant. These are my ages, which is our variable. And then I'm going to have frequencies along the vertical line, the vertical axis. I want to put down my boundaries as my scale. So I'm going to do, let's see, how many do I need? 1, 2, 3, 4. So this is going to be 15.5, 21.5, 27.5, and then finally 33.5. And then I use my frequencies, it needs to go up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not bad. Okay, 1, 2, 3, 4, 5. I'll just label the 10 and the 5. To construct my histogram, I just draw bars over each of these classes. So doing my first class here between 15 and 20, or 15.5 and 21.5, those are 10. So I'm just going to draw my bar. This is the easy part. Just draw my bar all the way up to 10. 21 to 27.5. This is going to be my second class. I've got 3 there. 1, 2, 3 lines up right here. And then finally that third class has 2. So 1, 2 looks like this. You'll also sometimes see these with the frequencies labeled on top, just for an easy read. So this is our histogram. We're going to construct a few different displays of data, a few different graphs. Next, we're going to construct a frequency polygon. These are called polygons, but they're also referred to as line graphs. I'm going to go actually up to my histogram and construct the frequency polygon to start with on top of the histogram. You wouldn't do this, but they're so closely related. It's a really nice way to look at them. In my frequency polygon, I'm going to use midpoints instead of my boundaries. So I want to go ahead and drop in my midpoints. I've got 18.5. So this would be 18.5. 24.5, and then 30.5. Instead of doing a bar, I do a dot above each of my midpoints. The midpoints is a representative age. So the frequency polygon really tells us that 10 people in my study are around 18.5. 3 people have an age of about 24.5, and 2 people can be represented with the age of 30.5. We connect the dots to create that line graph. But also I want to show that this is an exhaustive display of the data, meaning I've included everything. So I need to go up to what would be my very last midpoint, my midpoint outside of the data. So I'm going to add 6 to get that last midpoint, which would be 36.5. I have nobody here. And then I also want to include what would be my first midpoint outside of the data. So I want to go in this direction, subtracting 6, And that's going to give me a midpoint here of 12.5. And I would have a 0 there as well. Okay, so it's going to look like this. We would not do it on top of the histogram. So let me go ahead and redraw this one on its own graph. Let's see, so 18.5. Okay, so as I construct this one, let me switch back to my blue pen. My labels are still age and frequency. I want to start with my midpoint, the first one outside of my data, which was going to be 12.5. And then I include my midpoints, 18.5, 24.5, 30.5, these are all 6 apart, and 36.5, also outside of my data. My frequency scale is the same that I had on my histogram, 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. 1, 2, 3, 4, 5. There's 5. I go ahead and construct my line graph. I have a 0 at those midpoints that are outside of my data. And then I just plot my frequencies for the midpoints. So I've got 10 people with a representative age of 18.5. I had 3 people with a representative age of 24.5 and 2 people with a representative age of 30.5. See how well I can connect the dots here. Not too bad. Okay, and there's my frequency polygon. The next one is an ogive. This one is also a frequency polygon, but instead we're going to be using our cumulative frequencies. So as I label this one, these are still ages, but I'm going to change what was frequency along the vertical axis to cumulative frequency. And I'm going to label that F sub C for cumulative frequency, F sub C. When I go up to my frequency distribution, these were up 2s. I'm putting this on a number line, so I want to use my continuity adjustment. So I'm going to do up to 21.5, up to 27.5, up to 33.5. The limits worked fine in terms of just talking about the data, but in terms of plotting it, I want to use my continuous values. So the 21.5 is my first upper limit. As I'm plotting these, I am going to, let me get my highlighter. I am going to choose my lower limits and my upper limits. So I'm going to start at my lower limit of 15.5, where I have nobody because it's outside of the data. And then I'm going to go ahead and take my values, the 10, the 13, and the 15, and those are what I end up plotting. Okay, so back to my pen. Want that guy? Okay, great. Let's go down to 15.5. Okay, so this time I'm using my class boundaries, starting with my lowest class boundary of 15.5, and then moving through those class boundaries. 21.5 is going to be the cutoff for the first group. 27.5 is the next group, and 33.5 is for the last group. So I start with 15.5. That was outside of my data, so I have nobody. Up to 21.5. We need to go up to 15 this time, don't we? So let's just do 5, 10, 15. 5, 10, and 15. So up to 21.5, we had 10 people. I added in the next group. So ages up to 27.5 was 13. 13. And then up to 33.5 was 15. And then I do a line graph here. Whoops, I'm going to make that dot really big so it works. There and there. Okay, well, not the best looking line graph. But with this, I'm going to fix that guy. But with this one, I'm using my cumulative frequencies, which means I'm using my upper class boundaries. So upper class boundaries, and I leave that. I don't take it back down to 0. I start at 0, but I leave it at my final cumulative frequency, which was 15. Okay, next, the stem and leaf plot. This one is, I'm still grouping it, but I'm going to group it differently than I had done in my frequency distribution. So I don't need to worry about my frequency distribution table. Instead, I'm going to group this with my stem and leaf plot using the digits of the data. So I'm going to group these using my tens digits. Whoops, tens digits. Can you even read that? Okay, so using my tens digits. So I'm going to take one group that's going to be in the teens, one group in the 20s, and my last group is going to be in the 30s. And as I'm writing these, I'm going to have a group in the teens represented with the first digit of 1, 20s, first digit of 3, 30s, first digit of 2, 30s, first digit of 3. And what I do is I just go through and I'm going to grab the units digit. So as I grab this, I've got 1, 6, a 7, 1, 2, 3 8s, 1, 2, 3 8s, and 2 9s. To keep this a nice display of data, I want to make sure that I'm lining up my units digits as I move to the row of the 20s. So for the 20s, I've got 2 zeros. I'm lining that up with the 6 and the 7, a 1, a 2, a 1, a 2, a 5 and a 6, a 5 and a 6. Right? 0, 0, 1, 2, 5, 6. Good. And then for the 30s, I've got a 0 and a 2. So this is my stem and leaf plot. It's also a grouped display of data, but I'm grouping it in the 10s and the 20s and the 30s. This is one that I actually use in everyday life. I know, like actually in everyday life, right? When I'm looking at exam scores, because they're just naturally grouped into the 70s and the 80s and the 90s. But if I were to, these bars are not part of it, but if I were to draw a bar around each of it, I get a really quick look at how these are relatively distributed between each of my groupings of 10. Okay, so that is the stem and leaf plot. Now let's work example number 2. I've got some exam scores listed, and the first thing we want to do is to construct a grouped frequency distribution with 4 classes. So we're going to need to find the class width by doing the maximum minus the minimum divided by 4. To get those 4 classes. And then we know that we're going to need to round this up even if we get a whole number. Well, the first thing that I notice is that my first value here in the list is not my minimum. I actually find a lower value here at 62. So I can see that I should probably put this data in order. So I'm going to go over to Google Sheets. So I've already copied my data and I pasted it into Google Sheets. You can do this into Excel as well. I've got my data here. It's pasted as a row. So the first thing that I want to do in order to get my spreadsheet to organize my data is to put it in a column instead. So I'm going to go ahead and click, drag to highlight my data. And I'm going to do a Control C, or you can do Edit Copy. And then I'm going to grab an empty cell and I'm going to do a paste special. So I'm going to go Edit, Paste Special, and I'm going to choose Transposed. Transpose turns a row into a column, or vice versa, a column into a row. So now I've got the data organized the way that I want it. Let me get rid of this data so that it doesn't mess me up. Now I'm ready to organize this data. So I can click column A. I go up to data and I want to choose sort sheet by column A, and A to Z will do low to high. And then I've got it. So 62 is my minimum, and now it's put 98 there as the maximum. You can also do it high to low. I mean, it's completely up to you, and it just depends on what your application happens to be. So I could also do data, sort sheet by column, Z to A. So that will just reverse the order. So let me go back to, I'm just going to do an undo there. The other thing that you can do, and sorting does a really great job, so I don't need to, but you could also use a formula for the maximum. So I could go equals max, parentheses, highlight my data, and then hit enter. This will give you the minimum as well. So I can do equals min, parentheses, highlight your data again, highlight and drag there. And then we get 62. So I've got my maximum, I'm just labeling. I've got my minimum, and I'm ready to go ahead and compute my class width. And I'm going to use Excel here, Google Sheets, as if it were a calculator. So to do this calculation, I would just go equals, that tells Google Sheets that I'm doing a calculation in this cell. So equals, parentheses, I want my maximum 98, minus my minimum of 62, parentheses, divided by 4 to get a width for 4 classes. And then I hit enter. I get 9, but I need to round up every single time. Otherwise, I'm not going to grab the highest value. So I do need to round this up. So the class width that I actually want is this one here at 10. Let's go ahead and go back to our worksheet. Okay, so here's our worksheet. I've got a class width of 10, and I know that my minimum, so let me write that here. So my width is equal to 10, and my minimum was actually 62. So I'm going to use that class width to go from class to class. So lower limit to lower limit gets me from 62 to 72, 72 to 82, 82 to 92. To get my upper limits, I'm going to backfill. So 62 needs to go up to 71 in order for the next class to start at 72. So I do the same thing to 81 to 91. I don't have a number to backfill into my last class, but notice how these are also adding 10 to go from upper limit to upper limit. So if I add 10 one more time here, I end up with 101. That's a 91. Okay, so I've got each of my limits there. Let me go ahead and erase these, and let's change those into class boundaries. To change them into class boundaries, I'm doing plus and minus 0.5. This is my continuity adjustment. It's going to bump each of my classes so that the edges of the classes touch. Those boundaries actually touch. Think of it like a boundary between countries or a boundary between states. Those actually touch. So adjusting these out by 0.5, I get 61.5 to 71.5. I start at the same spot, 71.5 to 81.5. 81.5 to 91.5, and then finally 91.5 to 101.5. Next, I want the midpoint. The midpoint is an average of the limits. You could also use the boundaries here. So to find that first midpoint, I would take 62 plus 71 and divide that by 2. So if I grab my calculator, there it is. So if I go ahead and grab my calculator and I do my calculation here, I can do 62 plus 71 equals, and then I would divide that by 2 to get that middlemost value, and that's going to be 66.5. I also could have used class boundaries here. So if I do this as one single calculation, I would really want whatever I've got in my numerator in parentheses. Let me grab my calculator again. So I'd really want that in parentheses. So I'm going to do class boundaries instead, though. So 61.5 plus 71.5, close parentheses, divided by 2. And I end up with that same midpoint. So it doesn't matter if you use the limits or the boundaries to get those midpoints. So 66.5 is my first midpoint. So 66.5. To get to my other midpoints, let me just make that look nice. So to get to my other midpoints, I can continue to do this for each of my boundaries, or I know that these are also separated by that class width of 10. Makes it much easier. So 76.5, 86.5, and then 96.5. And you can just do a quick calculation. I like to do this because I often make a mistake, but let me go ahead and just check that last one. So if I do 92 plus 101, and I divide that by 2, I should get 96.5, and I do. So my midpoints are looking really good. Let me erase what I've got so we can fill in our frequencies. To fill in the frequencies, I want to use my ordered list. This list up above here is not going to be helpful for us because it's not in order. So let's go ahead and go up to Google Sheets and grab our ordered list. I'm actually going to get rid of this so I can start to do some calculations. So the first class went from 62 to 71, and that includes all of that data. So I can see that I've got 3 there. I could also do a count. Again, this is a small data set. I don't need to, but I just love teaching you guys these tools. So equals count parentheses, and I can go ahead and highlight the values that fit into that class. And we get the first class width of 3. So that's going to be, what was this, 62 to 71. And then I can continue to do these counts. So the next one's going to be 72 to 81, just putting a label there. And then I can go equals count again. So I want to start with 72 and go up to 81. So only 80 here. So that's going to be 4 in this next group. And then 82 to 91. Let me put that last group here while I'm thinking about it, 92 to 101. And then I can continue to do my counts. So equals count. I'm using the limits here, parentheses. Let's see, this starts at 82 and it includes 91, but I don't have any. So I end up with 3 here. And then finally for that last group, you can of course count these by hand. For that last group, 92, I don't have one. So I'm just going to grab these last values, enter. So I've got my frequencies there of 3, 4, 3, and 5. Let's go ahead and transfer those over to our worksheet. So my frequencies are 3, 4, 3, and 5. Now I'm going to do my relative frequency. To get my relative frequency, I need my total. My total is N, and it is the sum of, that capital sigma means sum, the sum of my frequencies. So that's going to be 3 plus 4 plus 3 plus 5. If I add those together, I get 15. So as I'm looking for these relative frequencies, it's going to be frequency divided by N. So for the first class, I've got 3 out of 15. The second class is 4 out of 15. 3 out of 15, and 5 out of 15. You can change each of these into a percentage or a decimal if you want. I'm going to go ahead and leave those here. Just make sure you're reading the instructions so you've got the right form, but I'll go ahead and leave those as fractions. The cumulative frequency is a running total. So what I'm really doing here is I'm finding my values up to the upper limit. So this would be up to 71, up to, so I want all the data up to 81 for my second cumulative frequency. The third one's going to be up to 91, and then finally up to 101. So for all the data up to a value of 71, that's just my first frequency, which is 3. If I want all the data up to 81, that's going to be 3 plus 4, which is 7. All of my data up to 91, I need to add another 3, and that's going to give me 10. And then all of my data up to 101, which is everybody, is 15. So if you've done this correctly, your final cumulative frequency is going to match the value that you found for N. That will work every single time. Next, we want to go ahead and construct some displays of data. I'm going to make this a little bit smaller so that we can see our grouped frequency distribution. I want to start with the histogram. So let me go back to my blue pen. For the histogram, I want to go ahead and draw a horizontal and vertical axis. These are exam scores and frequencies along the vertical axis. My exam scores need to be divided up by my class boundaries. So I'm going to use those boundaries, and I just do a quick count. I've got 61.5, so I've got 1, 2, 3, 4, 5 of those. 1, 2, 3, 4, 5 of those. And then I'm going to go ahead and label kind of carefully: 61.5, 71.5, 81.5, 91.5, and finally 101.5. And then I am using frequencies. Those go up to 5. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And I'll go ahead and just draw my bars using my frequencies. So the first bar is going to go up to 3. The next bar goes up to 4. More or less straight. The next one is also 3. And then that last one is 5. So up to 5 for the last one. I like to label these with the frequencies on top just to make it really easy and quick to read. Next is the frequency polygon. For the frequency polygon, I can think of this as being superimposed on top of the histogram. It's the same information, but I'm using midpoints instead. So I'm going to be labeling with midpoints instead, and I'm going to put just a dot for the frequency of that representative midpoint. I'm going to be connecting those dots, but in order to finish this, I also need the midpoint on the outside of my data, both at the start and at the end. So I'm going to go ahead and go up to my midpoints, and I'm going to add in the first and last. Remember, these are separated by my class width of 10. So I just want to subtract 10 to get my initial midpoint, which would be 56.5. And I add 10 to get my final midpoint, which would be 106.5. So I want the midpoints outside of my data so that my frequency polygon has a place to start and a place to end. Okay, so back to my blue one. So I have 1, 2, 3, 4, 5, 6 midpoints. So 1, 2, 3, 4, 5, 6 midpoints. So I can go ahead and label these. So 56.5, 66.5, 76.5, 86.5, 96.5, and 106.5. We still are using these to represent scores. These are now representative scores for each of my classes, and my frequencies are still the same. So my vertical axis is still frequencies, 1, 2, 3, 4, 5. And then I go ahead and start to draw this. Well, for my first midpoint, it's not actually in my data, so I know I'm going to have 0 to start. And I go ahead and label each of my midpoints. So at 66.5, that represents the first class. There are 3 of them. 76.5 represents my second class. There are 4 in that group. 86.5 represents my third class. There are 3 in that group. 96.5 represents my last class. There are 5 in that group. And then 106.5 is where I end. There are none in that group. We connect the dots. Having those midpoints outside of our data shows the reader that this is an exhaustive list, which means that I've included every single thing within my group of data. Next is the ogive. The ogive is actually a cumulative frequency polygon. So I'm going to be using my cumulative frequency values here. So as I label this, these are still my scores across the bottom, but these are cumulative frequencies along my vertical axis. Because these are my up to numbers, I'm going to be using the numbers that I've got for those cumulative frequencies. But I do want these to go up to the outer edge of each of my classes. So I do need to make just one adjustment to what I've got drawn there. I really need my 0.5s here. Again, this shows that this is an exhaustive list. I don't know if 0.5 will show up, but you get the idea. And then I also need a starting place as well. So I do start at 61.5, and then I use each of those class boundaries, the upper class boundaries. So I've got 1, 2, 3, 4, 5. So I need a starting place and an ending place. So it's going to be 5 of them. So 1, 2, 3, 4, 5. And then I started at 61.5, right? Yeah, 61.5. Okay, so this is going to be 61.5, 71.5, 81.5, 91.5. Then my last group includes everybody up to 101.5. For those cumulative frequencies, I need to go from 3 to 15. So let's just kind of eyeball this a little bit. Let's just go 5, 10, 15. And we will adjust as we go there. Okay, so 5, 10, 15. I'm going to make this smaller so I can see everything at the same time. Perfect. Okay, so there is 0 when I start at 61.5. So that's my starting place. That's actually outside of my actual data. But 71.5 includes 3 of my data values. So up to 71.5, I've got 3 of my data values. Up to now 81.5, that's 7 of my data values, so 7. Up to 91.5, that's going to be 10 of my data values, so that's going to be 10. And then up to 101.5 is 15. and then I connect the dots. This is a polygon, same thing as a line graph. Okay, and there we go. And we just end there at 101.5. Finally, I want my stem and leaf plot. To get my stem and leaf plot, I want my data in order, and I'm going to group these differently. I'm going to group them by my first digits. I'm going to group them by my tens units. So I've got the 60s, the 70s, the 80s, and the 90s. There's nobody in the hundreds. So I'm actually going to just organize what I've got here just a little bit differently. So I'm going to make this smaller, and I'm going to grab my data so that you can see it as well. And it's already in order. Okay, great. I'm going to make this a little bit bigger as well. Okay, so now whoops. There we go. Okay, so let's go ahead and put this together. So there we go. Okay, so in the 60s, I have a 62 and a 63. So a 62 and a 63. In the 70s, I have a 71. Notice how I'm lining up my units digits. So each of them has a column. So 1, a 2, a 7, and an 8. For the 80s, I have a 0, 2 2s and a 9, a 0, 2 2s and a 9. And then for the 90s, I've got 2 3s, a 5, a 7, and an 8. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are grouped differently than my classes. These are grouped instead using a group of 10 based on the 60s, 70s, 80s, and 90s. That's why we're seeing different values here. So this is my stem and leaf plot. Well, as I look at these, I can see that I've got, this is uniform and symmetrical. This would be if each of those groups had the same or almost the exact same number of data values. This one is skewed to the right because it has a tail on the right. So something that tapers down to the bottom, we call a tail. So that one's got a tail on the right. Most of the students or scores or data values are over here. So we call it skewed to the right because we've got that tail on the right. The next one is symmetrical. You might think of this as the bell-shaped curve. So the bell-shaped curve, also called a normal curve. We're going to work with that guy a lot. This one is left skewed, again, because I've got a tail, but this time the tail is on the left. We're going to be working with those four primarily. This one is bimodal. Mode is the most frequent, and we've got 2 modes here, but it's still symmetric, so it looks the same. If I draw a line down the middle, it looks the same on either side, so still symmetric. Bimodal and skewed right. So we have 2 groups where my students are landing, so bimodal, but it's skewed to the right because even though we have that bimodal, we can still see this tail behavior on the right. So tail on the right. Let's take a look at some scatter plots and regression models. We're going to do quite a bit with linear correlations and the correlation coefficient as we look at scatter plots, so another display of data. If our data lines up like it does here in number 1, we can assign it, or I should say with a correlation coefficient of 1, the first graph, we can assign it a correlation coefficient. My correlation coefficients only range between, these are our R values, between -1 and 1. And it's a number that we give to how far the data is. It's actually using these values. Let's see, where could I draw it? And it's minimizing the box where we have the data point and the point on the line as the corners of the box. So it's minimizing the area in that box. So we call it the least squares line is a good way to describe it. And we want to minimize the area in those squares. Well, we can quantify this using the correlation coefficient. If we have 0, that means that we're scattered. That would be this one. So that would be no correlation. There's no pattern whatsoever. If it's -1, that means that our pattern is going down. And if it's close to a positive 1, that means our pattern is going up. And they can be anywhere in between these values. So you'll see that we have a perfect positive correlation of 1 and a perfect negative correlation there of -1. And you can see the closer we get to 0 with these, the closer we get to 0, the more spread the data gets, the spread away from a line the data gets. And then anywhere in between, right? For sure, anywhere in between. We're going to use statistics to decide which of these values, and it just depends on so many factors, but which of these values really is giving us a strong linear correlation. Okay, so between 1 and -1, we want close to one of these to be able to say that we do have that linear behavior. Let's look at an example. So we're going to use the data to analyze the linear relationship between variables. We're going to create a scatter plot first in Google Sheets, and then we'll do one in Excel. So you want to copy and paste this data into Google Sheets or Excel. Either one is fine. I've already done that, but you can highlight and then do a control copy. Let me go over into Google Sheets here. And what we have here is the dollar amount of the bribe that students give me versus the grade that I can guarantee them. Okay, so for 25 bucks, I'm only going to guarantee you a D, passing grade, $62. But for $150, I will guarantee you at least a 93, an A- out of the class. Is that an A-? I think it's an A-. I want to plot this data. So I want to take a look at the scatter plot. So I'm going to go ahead and highlight my data. And I'm going to ask Google Sheets to insert a chart. Excel will do the same. If you have your chart icon up here, you can just click on your chart icon. It takes just a second. It guessed. I actually don't want the line chart. I want a scatter chart. There we go, scatter chart. It looks pretty linear, doesn't it? So I'm going to go ahead and do one more thing. And this is just not obvious. So watch my steps here. I click on Customize. I'm going to go down to Series. This is the data, the series of data. I'm going to scroll down, and I do want the trend line. This is the best fit line. So I click on trend line. I continue to scroll down, and I want the label to be the equation. So it gives me the equation, and I want to see what R squared is. R squared only spans from 0 to 1, so it wouldn't tell me if it was negative or positive. But 0.973 is a pretty good R value. We could take the square root of that to come up with R. So R squared is just another way of looking at this. So from here, I can tell visually that I've got a pretty nice line of fit there, pretty close to each of my data values. But I can also tell using my quantity, my measure R, which has been squared, no big deal, that gives me 0.973. If I wanted to do, let's see if Google Sheets will do this for me, equals SQRT, yeah, square root, perfect, of 0.973. Okay, there's my R value. So that would be R. So there's my R value. Either way you look at it, it's a really nice correlation. The other way to come up with a linear regression and to look at the R value is to do this in Desmos. Desmos, though, does not like the data in rows. Instead, it likes it in columns. No big deal. We know how to do that, right? I'm going to delete this guy so it's out of my way. So I'm just going to go ahead and take the bribe group. I'm going to edit, copy, edit, paste special, transpose. Oh, it did. Let me undo. Let's do edit, cut, grab an empty square, edit, paste special, paste transpose. Okay, better. Do this next one. Edit, I don't know what I did wrong. Edit, cut, grab the next blank cell so we get 2 rows, edit, columns, edit, paste special, paste transposed. Okay, now I can go ahead and highlight my data. One more thing, if you're having problems getting it into Desmos, sometimes it does not like copied in data. So you want to go to Format, Number. I know it's usually already clicked on automatic, but by clicking on it, it puts it in a format that Desmos understands. So I'm just going to go here. I've got all of my data highlighted. I'm going to copy it. So I'm doing a right click and copy, or you can do Control and then C to copy. I'm going to go ahead and get into Desmos. I'm going to grab a blank tab, type Desmos. Yes, please start graphing. I'm going to put my cursor, which it already is, into an empty cell there, and I'm going to do Control V to paste. How nice is that, right? So there's all my data there in Desmos. You can mess around with this graph a little bit if you want to, but it's looking pretty good there for me. And then I'm going to type in Y1, it automatically subscripts, so Y1, and that matches the data value above the second column, tilde, which is in the upper left-hand corner of your keyboard, MX1 plus B. So it gives me the equation of the line, and there's that R value 0.9865 that Google Sheets had given us. Okay, so there's that one. And I've got, this was Desmos. So we did part A and we did part B as well. Okay, so we've got one more to do here. We're going to state the regression type and then the type of linear correlation, the regression equation and type of linear correlation. Shoe size and grade. So do you think that shoe size would be related to somebody's grade? Probably not, right? Maybe, I don't know, it's just made up data. So I've already copied this, but you might want to just highlight all of this and copy it and then paste it into Google Sheets or Excel. So I've got it here. Again, I'll do it both ways. So I'm going to highlight all of my data and I want to insert a chart. Insert chart. Okay, so there's my scatter plot. Maybe it almost looks like it has an upwards trend, right? I'm going to go to Customize, Series, scroll down, Trend Line, scroll down, Show R, and label using the equation. So this is my equation right here. It says grade equals, but you could write that as Y equals 2.9x plus 43.7. We've got the R value there, but we really need to do a square root to get not the R squared, but the R. So SQRT, it gave me R squared 0.242. Oh, and I need a parenthesis. Okay, there we go, 0.242. And it gives me, there's my R value, 0.49 and so on. So not a strong positive correlation, but it is a positive correlation. Okay, so there's that. So Y equals 2.9x plus 43.7, and we can get our R value not very strong. Let me delete this, and I'm going to go ahead and put this into Desmos. Highlight my data, edit, cut, grab a blank cell, Control V. Oh, that's not what I wanted. Control Z, edit, paste special, transpose. Oh, better do it again. Okay, so edit, cut, blank cell, edit, paste special. Let's forget paste special, transposed. Okay, do it same for the grade. Highlight that one, edit, cut, edit, paste special, transposed. Okay, there we go. I'm going to, now I can do a Control C to copy. I'm going to go over to my Desmos. I'm going to delete my last equation and data, doing a Control V to paste. Okay, so Control V to paste. They're much more grouped here, aren't they? So I can mess around with this a little bit, right? But you'll notice that there's a little magnifying glass here. It's a zoom fit. So if I click on the magnifying glass, there, it gives me a nice display of my data. Okay, now I want to type in that regression equation. Y1 tilde mx1 plus b. If you had left your data from the last example up here, it'd say X2 and Y2. I didn't. So I can go ahead and do the data that's labeling, or the X and Y that are labeling my data. Okay, so my R, okay, so there's the R value that we got. Notice that Excel rounded, but Desmos doesn't round as much, which is really nice. And it's giving us that so-so positive linear correlation. So that's how to do that both in Desmos and in Google Sheets. Two really, really great resources as you're working through this data, and we're going to be working with those programs all the way through. Part of my goal is not just to teach you the statistics, but also how to easily get to the numbers so that we can focus on what it all means.